so I have to, okay. Got it. So this first day, we are going to learn step by step, and you have a first question, which is just a question: is LIGO easy? Like when I was learning Rust, it took me too much. Yeah, we are going to see that Js LIGO and LIGO mainly in different dialects is quite easy to learn because it's a traditional language. No features like memory management and type system and so on. So it's really it's much more easier to learn. So it's easier as a JavaScript or Java and so on. So this is the same level of difficulty to learn this language. The most difficult is to learn the language and to use the right properties and the APIs for the blockchain. So this is the deal. So first, we are going just to start this session, and I post on the chat a GitHub endpoint. So if you want just to set up your environment, because it takes time, it can take time. So you have two possibilities. The first one is to use what we call the remote execution thanks to the Gitpod. One remark: if you want to start with Gitpod, you need a GitHub account. Otherwise, you can do a local execution. Just starting downloading VS Code is not yet the case. You can also activate sorry, LIGO plugin, and then after you are just to to download LIGO, and if you have Docker, you can use Docker directly. It's much more simpler. It's the simplest solution. So what we're going to do today is I'm going to use it thanks to Gitpod. So I'm going just to start my Gitpod instance, and during the setup, I'm going just to provide you a short description of what LIGO is in general, and then after we are going to start and learn step by step LIGO. So when I'm saying step by step, is based on what we call koan, koans, I think in English, and this is a capability to learn a language based on tests. So we have some tests, and you learn the language driven by tests. So then after you have the GitHub, so you can see how we can write unit tests also in LIGO, and just to be sure that everybody is okay, I'm just going right now to start just a short description. It will take around 20 minutes, no more. So first, we're going to introduce LIGO, which is a programming language for writing Tezos smart contracts. So this language is dedicated right now at the moment to the blockchain. So why LIGO? So we know that we have Michelson on top of the blockchain, which is Tezos, and in Michelson it's already a language. So we are able to write application using this language. But if you already try to do some Michelson code, it's not so high. It's not a high-level expression language. It's a stack-oriented language. So you have to express first some types. So Michelson is it's a language with static types, which is this one is important because we are to see that the static types are going to should be expressed also in LIGO, even in JavaScript dialect. So you have the parameters, the storage, and you have some code. And as you can see, we have the drop, push, nil, pair, and so on. And here you have really how to say a low-level instruction to deal with the stack. So writing such code is really difficult, and it's not really how to say easy to understand. It could be, you could write code thanks to Michelson if you want, for example, really effective and efficient and really optimized code. So if you need really optimized code, you can try Michelson directly. But we are going to see that the compiler also has some capabilities to compile, to provide and to do a strong optimization, and in order to prevent gas consumption. So since everybody cannot really write Michelson, we provide, so some companies like, for example, Nomadic Labs and LIGO provide some languages. We have some languages like SmartPy, for example, which is a Python-like. Yeah, you have also Archetype, which is a kind of a high-level language with a nice DSL. But with capabilities to deal with properties and values bring by the blockchain. And you have LIGO. You have other one, but this is mainly the three languages we are in LIGO, except Michelson, of course. So the goal is to reduce the barrier in entry and minimize the risk of bugs, of course. So we're going to see how. And the solution is to provide a high-level language that compiles to Michelson, because this is the target. And one choice which has been made by LIGO is just to have different syntaxes in order to cater different developer tastes. For instance, people coming from the web development where know TypeScript and JavaScript. So we provide a Js LIGO, which is a JavaScript syntax with imperative feature. Some people coming from like me, from which are old, which play with Pascal, we have a Pascal LIGO, which is the first syntax which has been implemented. And for people which are really fond of functional programming, you have Camel LIGO. We are Reason LIGO, but we are going to deprecate it soon. So be aware that this syntax should be dropped and forget. So this is mainly why the foundation of and why we provide LIGO on top of Michelson. So the LIGO foundation. So as mentioned, each syntax is close as possible to the language it has been from. For example, we have Pascal LIGO, which has been inspired by Pascal, with an imperative developer experience. When I say imperatives, you have a sequence of instruction, and you have also local assignments and mutation. When I say local, you cannot, for example, define structure with mutation. It's just mutation related to variable and in a given block of code. Then after we have the Camel LIGO syntax, which has been, of course, inspired by Camel, Objective Camel, or Camel if you prefer, which is a functional style. So functional is computation, an evaluation based on evaluation of mathematical functions. So you define small functions, and then after you compose this function in order to have the program. So the composition replaced, for example, the sequence you have on Pascal LIGO. You also have the let-in construction, which also mimic the sequence. And Reason LIGO, which should be deprecated soon, which is the same level as Camel LIGO, which is a functional style also. And the last one, which is a Js LIGO, which is a JavaScript inspired, and TypeScript, because we have also the type definition and type specification. So it's between JavaScript and TypeScript. And the syntax which has been chosen has been inspired mainly by TypeScript, JavaScript mainly by TypeScript right now. Today we're going to just introduce Js LIGO, but be aware that all the concepts which have been introduced in Js LIGO already exist in Pascal LIGO and Camel LIGO. This is just the main difference is just the syntax, no more. And so the interoperability, which is important. Once you choose a syntax, you are not forced to use it every day. For example, you can write some piece of code in Camel LIGO, for example, in a given file. You can write some piece of code in Js LIGO in another file, and you can use both files in a third one. So you are able to use the syntax you want. And for example, if some people in your team prefer to use Camel LIGO, they can choose it. If other ones want to choose Js LIGO, they can use it, and you can merge and use both syntax because each syntax are interoperable. So Camel LIGO can call code which are written in Js LIGO, and vice versa, and so on. So there's no trap. Once you choose a syntax, you can change later and continue a program in another one. Okay, it depends if you want to have functional style or imperative style. This is the deal. A language is it's a first step, but a language without tools it's useless. Frankly speaking, right now nowadays we are not in the 80s. So we have a first tool which is a CLI, so the command line interface. The CLI lets you different operations. The first one, the compilation of the contract, which produce Michelson code. The second one is the capability to compile expression, LIGO expression. Why this is expression compilation is mandatory? Once you decide, for example, to originate a contract, you have to give the Michelson code, but also the initial storage. Initial storage is an expression. So the origination to the contract Michelson is done thanks to the contract compilation, and the expression for the storage is done thanks to the expression compilation. We already have some capability to run tests. So we're going to see we have a test framework, testing framework, which is really nice and really rich, which lets you do some unit tests, but also integration test. So what we call end-to-end test, which lets you originate a contract, play with, and so on, and do some verification and try to test your properties which are linked to your contracts. We have also the mutation testing, so a capability to operate some mutation on the code in order to see if the code is robust once you decide to modify some values. And soon we are going also to have some what we call property-based testing. So it's an ongoing work right now. We also have the capability to have some dry runs, which is just a traditional dry runs. And running testing dry runs also give you some gas estimation. So you have the capability to see the gas consumption once you do some tests. So if you want to do some metrics, you can do it on the gas consumption. We have no test covering, for example, tools right now. It's not yet on the pipe, but we have to think about it. And finally, we have the capability to use package management. This is done thanks to Easy. This is on top of NPM and non-modules. So once you write a library in Js LIGO or Pascal LIGO or Camel LIGO, you can provide it thanks to the package management and share with the community. And all this operation is provided by the CLI. So you have the CLI. The CLI lets you install package management, install packages, and so on. So this is quite new because we have no real packages are coming soon. I think the first one which should be done. I have some discussion with some developers, which should be we have the test framework, but something a test engine with the feedback and the report and so on, for example. We have a web ID. So this is the current one, but it should be replaced later. Gas fee we compare to other layer. We have to see the specification. It's related to each instruction as this gas fee. So we have the web ID. And this one should be replaced soon by a brand new ID coming soon, which has been built on top of Ethereum, I guess, web ID also, in order to have the same capabilities, which look like VS Code, the same as VS Code. We have also a VS Code plugin, which lets you also right now syntax correction for Js LIGO. This is brand new also. It has been provided this week, so it's really brand new for us, and we are really happy to have it. So the VS Code also, you have the capability to have some discussion with the compiler because you have the LSP, and so on. We have also, of course, if we have VS Code, we can bring everything in the web browser thanks to Gitpod, because Gitpod is just a how to say, a Docker image which is created on the cloud and lets you have your VS Code on the web, and you are in the direction with this Docker or this Docker instance. You have the capability to have the terminal and so on. So everything you have in VS Code is already present in Gitpod. And we have more. We have a syntax exploration with our VI, Vim, or Emacs. We have also tools like tutorials. So you have academy.ligolang.org, which lets you step by step introduce the language, as we are going to do today. And this one covers each syntax. So if you want to perform the same exercises, you can do it in Js LIGO, Camel LIGO, and so on. So you can improve your knowledge and increase your skills thanks to this academy.ligo.org. So is free access. And finally, in order to increase the knowledge and the knowledge base, we are building also a LIGO catalog. So soon we will also have a website dedicated to this one, which should be a LIGO lib, which is in construction. This library contract lets you have some aspects and how to say, learn how to do some gaming, so NFT factory, and so on. Some randomness, big array, which is a library, and more and more. So this is a base of smart contracts, which should be seen as templates. So you can pick up this templates and use it as is, because it's a free software. So it's a MIT, it's under MIT license. So you can duplicate and then after tune the code and so on in order to be more efficient and so on. This is finally the presentation. So I have no more to say about LIGO. So right now we are going to learn LIGO step by step. Yeah. And one important feature in LIGO is you have to write types. So types are really a foundation to write safe code. But we also have to write tests in order to have some safe code also, to be sure that we have the types which offer security and safety, but we also the tests which offer also some, how to say, capability to have the safety and in order to prevent regression in the codes. Okay, so I'm going to start my Gitpod. So right now my Gitpod has been started. So we have I'm pretty sure we have the LIGO command, which is already set up. So if you start it the first time, is going to how to say, I forget the name, to download it thanks to Docker. So I hope that everybody is ready to start right now. So how we are going to do it? We have three directories. The first one is the lib with all the commands. So everything has been ordered with different themes. So we are going to do step by step. So the program is, I'm going to do it with different steps. First, I'm going to just introduce the exercise. I let you do it I let you a few minutes to solve it, and then after I solve it for you, and we run the test and so on and so on. And we are going to I never check code space, to be honest. I never check. So if you do it and if it works, you can give us feedback. I will do it. I just try code space. I don't do it because I have access. I have this access since 2 weeks, I guess, something like this. Then after we are going to do step by step, and we are going to learn really step by step. So the first exercise are really simple, but let you to see how we are going to do it. So we have the first one, which is lib. The second is solution. Okay, so you have the complete solution of all exercises, because I guess the last time I do it, I can do only 60% of the core. And then after you have the test, and for example, we can open the test. We have, so this is quite natural and traditional, how to say, unit test. So I don't know if you see my screen with my VS Code and my GitHub Gitpod. Is it okay for you? Did you see my screen correctly? Yes. Okay. Okay. So here, you just to show you how we write some unit tests. So here I write some just command function to how to say, to ease the unit testing. So you write we have just assert equal in the check. Check is in just a library which is provided here. So we can see how the assert equal is written. It's just an equal, and equal is just a polymorphic function. And then after we write cases, and then after we execute the cases. So each test cover the core. So we're going to just start. So each file, you have a given set of exercises and also the reference in the documentation. So if you need more information, you can, for example, open the page.
Didier, just Didier, could you please
yes?
increase the text size?
It's increase?
Yeah, increase the text size.
Like this? It's better?
This a little bit, one more point, please. Yes,
it's better?
This is good. This is good. Thank you so much.
Thank you. No problem. So I'm going to close this one. So you have the documentation. So you go through the documentation in order to learn, but I'm going to also introduce the concepts. So we are going to start. And just to start, we are going to deal with what we call the native type, which are string, integer, natural. So natural is, as usual, is integer, which are the 0 and upper. Tez is a native type, which is in fact mandatory to manipulate Tezos. So the accuracy, the cryptocurrency, which is a Tez on the blockchain. And you also have Boolean. And we're going to see that here we have some to do. So what the game is just to replace this line of code to do by the right code. So here, what we are going to first do, we are going to make all the tests. So here,
Didier, I'm very sorry again. Could you also share the editor link, if you don't mind, with the audience on chat?
Sorry?
Could you share the editor link on chat?
Yeah, I already share it in the first message, and you just have to let me redo again. You just want on the GitHub project.
Yes. If you can do that, I will pin it.
Project. You just have to click on open in Gitpod.
Okay.
That's all.
All right.
Okay.
Okay. Got it. Thank you so much.
I'm going to set up in the to send it to write in open. So procedure. Open the GitHub project and click open in Gitpod. There are some typos, sorry.
Thank you.
So, no problem. So the first one, it should be, we're waiting for the screen with a string, which is hello. We're waiting for one, which is an integer one as a natural, and one as a bool, and one as a tez. Sorry. So I let you read the documentation, try to find, and then after I'm going just to solve these small exercises, just to let you introduce the how to say, the native types, yeah. So I let you, I take 2-3 minutes, I think should be okay. And then after I'm going just to solve the exercise. If everybody is okay with this this procedure, we're going to do this like this. So I let you just try to read. This is important because we do it in order also to have some feedback about the documentation, because sometimes we found that finding it difficult, the documentation? What is difficult? To open the Git pod and to have the Git pod ready because you need the GitHub accounts and something like this? Don't know. Okay. I'm just waiting for the response. So, for example, I'm going to just do it the first one, which is really simple. Since I'm waiting for the string hello, this is LIGO long. Oh, really? So I'm just going to execute the code right now. So as you can see, it said that the first test, which is I'm expecting hello, it's a success. So this first one is okay, it has been solved. And this say right now we are waiting. We have an error here. We should return 1 at live 16, and live 16 is here. So you have to solve this exercise. This is the next exercise you have solved. So the integer is quite easy. Also, I'm doing just to do the first. The two first exercise. So we do also a make all. So the one I expected is okay, it's a success. And then after we're the 19. So we have to solve this one. And I let you read the documentation and try to find the solution and the right solution to write this code. So I let you, okay, 3 minutes. Difference between NAT and Tez. Yes, it's important. Natural is really important because sometimes you need strong properties. For example, if you want to deal with, for example, a number of tickets, or for example, you have NFT and you have a number of a given number of NFT, this number of NFT should be a natural. You could not have negative number of, for example, of NFT. So the natural lets you have a strong property, which is this value should be 0 or upper, never something which is negative. So this is one capability for natural. And Tez, the difference is Tez is really dedicated to the currency and the cryptocurrency, to the Tezos. And this is important because once you do some transaction, you have to give some also, you can set up amount of Tez. And the only capability to do it is to use the Tez, the Tez type. So you just separate the the space of values, the values which are dedicated to naturals, and the other one to Tez. And don't let you manipulate natural al Tez and to do some mistakes. So this is just to prevent mistakes and just to increase the security on the code once you decide to manipulate cryptocurrency or for values like the number of tokens and so on and so on, just to prevent you to have wrong manipulation once you decide to use one Tez in place of one natural. This is forbidden. Okay, just 1 minute. Oops. Okay, so if we go through the documentation, which is here, we see that if we want to deal with natural or Tez, we have the as something, which is a construction. So in Js LIGO, it's as this one. In Camel LIGO is different, but you have the same capability, same difference. We can see, for example, in Camel LIGO, you just have to write n. So 12n is for naturals and so on. And for Tez, you write Tez. On Js LIGO, you have to use the construction as. So as we can see here, if we want to decide that one integer is a natural, you should something is kind of cast, in fact. Huh? So you can write it like this. So here, we're waiting for one as a natural. So you just have to write this one using as. natural. So we can execute the code, of course. And here, what's expected is one natural, so it's okay. So this is the idiomatic style in JS LIGO to have naturals. Okay. We also have the same for Tez, so we can write and was Tez, and then after we can also execute the code. So we have Tez and new Tez. We how do you execute the code? You have the make file here. Just make. So we have just a make file, and just show you just a make file. You have the different usage, and make file in order use behind the scene a Docker image with version 42, which is not the last one. I guess the last one is 43. And then after just a make file. So you can use it directly with Docker, or I guess you can also do some LIGO. I guess LIGO. Sorry. LIGO run test K01, I guess. Yes. Like this, okay. Oh, we have a test fail, which, yes, this one is not solved, so we don't solve the last one. Sorry, which is here, which is the Boolean. So we are waiting for the message. We are waiting for, in fact, in line 25, which is here, we are waiting for the true. So we are going to just send as a return true. And that's all. So here I'm going to just execute it thanks to LIGO run test, or you have the make. I use make file because you have a bunch of commands. So in order to use it, the second one and third one and so on. But you can use the LIGO command directly. So here, what we can see is just to have native values and so on. And we don't forget, once you want to use Tez and naturals, you have a given native type, and also a natural and idiomatic construction in order to have these native types. Of course, if you want to write this one, the compiler complains saying that -1 is not a natural, okay? It's an int. So the compiler for you, once you write a static value, you have a static value directly, you have the value which is checked, fetched by the compiler. So the compiler checked the value here, you know, so you can write stupid code, for example, like -2 as natural. So we're going to see also we have some capabilities. Once you have, for example, an integer, and you can transfer and transform this integer and naturals and so on. So then after, we're going to see how to manipulate these numerical types, numerical types. And yes, you can use also make K01. This is other. So you have a different possibility to execute a test. So the second step is you're going to see how to manipulate these values like integers. So we have the infix operator, which is plus, for example, which lets you do some operation. We have the minus and so on. And then after, we are going first to manipulate integer, naturals, and Tez, and do some addition. So I'll let you do this operation right now. So you have here, in this first column, we have just some function which take nothing. And here we are just writing some first function which takes values. For example, the add int, which is an integer addition. We are waiting for two integers, which are called n1 and n2, and we're going to send as a return, we are going to return another integer. So here the function should do the addition of n1 and n2. So I'll let you work on this four functions, which are really simple one, and let you work during 3 minutes, just to let you work and read the documentations and after, and to see that we have a kind of what we call ad hoc polymorphism, which is we have the same operation, but for different types. And just to see, we can add integer, we can try to add integers with naturals, naturals with naturals, and Tez with Tez. Okay, so I'll let you work 3 minutes right now. if it's too slow, let's write it on the chat. If it's too fast, also, okay. And if you need some clarification and so on, yes, in Boolean we need to write true or false. Is there any option like Python or JS? We had yes, you have to use a value which is you have to use a type which is option. Option and of Boolean. You have what we call tiers exclu. Boolean, it's true or false, nothing else. And if you want something else which is true or false or maybe nothing, you have to use another type which is option, like in I guess which is a question mark in TypeScript, in Kotlin, Swift, and so on, or option in for example in Scala or in Java. And same in OCaml or Haskell if you want. So it's the same school as Haskell, OCaml, Scala, and Java. You have a dedicated type construction which is option, and you have to see if it brings some value or nothing. You don't have the undefined like. Okay. So just 1 minute again. So we are going to see the optional later. Yeah, in the K10 option. Cool. You drink some water again.
Right, while Didier takes a break, I would like to inform you all that all the questions will be addressed at the end of the session. If any questions are missed out by Didier, please do share them at the end of the session, and do keep the chat box as minimal as possible so that we do not lose out on the questions. All right, Didier,
Okay.
go.
Okay, it's okay for me. It's okay. So I don't respond to the question right now, except at the end.
Yes, thank you very much.
Thank you very much also. Thank you. So we can solve it quite easily. So this one, in fact, use basic construction and basic function, which is provided by the language. So the addition here, so you have entry also. I'm searching my mouse. Oh, here it is. You have the entry points for the documentation again, which is the same one. So you have the capability to some addition, which is done thanks to the plus infix operator. So just in order to solve this problem, you just have to write this code like this, which is n1 plus n2. That's it. So and execute the code. Oh yeah, I have to save the code, of course. Yeah, it's okay. It's okay. The same for integer and natural. Sorry. Okay, and one important thing which should be noticed here is once you decide to add a natural to an integer, you have an integer as a result. Okay, so you lose this property because the first one is an integer, so it could be a negative one, and since it could be upper than the n1, so it could be also negative. So you lose some properties once you decide to add an integer with the naturals. You have an integer. Okay. Of course, if you decide to add the naturals with the non-naturals, since the addition how to say prevent and preserve the property, you have a natural as a result. So you have just to have the same one, which is n1 to 8 plus n2. And then after, for the test is the same. So once you decide to add a test with another test, it's still a test. So same is plus n2. So here the compiler is able to decide which plus is going to do regarding and thanks to the types which is provided by the function as a parameter type. So here you provide everything for the addition. So then after we're going to apply the same principle, but for the subtraction, in order to subtract some value with another one, and we are going to see that we are going to lose some properties once again. So I'll let you do it 2 minutes, because it could be it should be done quite. It's quite easy and quick to be done. So the most important here is the fact that we lose some property once we decide to add naturals and integer. Of course, we cannot add Tez with integer or naturals because Tez is it's not a subset. Naturals is a subset of integers, so it's quite easy. But Tez is not a subset of something. It's a Tez, so it's an independent type. You have no relationship with integer or natural, as we do, for example, with naturals, integer. We have set inclusion. So naturals are included in integer. This is why we permit this kind of manipulation in addition between integers and naturals. One important thing when you write the code, if you omit this character, you should have some syntax error, which lets you that the semicolon here is missing. So it tells you that in 941, the character is not able to understand the export keywords. Because something is missing. So mainly he tried to drive you to give you the solution. Instead of expecting a semicolon just before. So you just have to do this one, and then after you have the code compiles correctly. Okay, so be careful once you write some piece of code, you have to write the semicolon each time, between each definition. This is really important. Otherwise, compilers complain. This is not the same, for example, in Js LIGO and so on. This is very typically enforced in JavaScript. So we can do the subtraction right now. Okay. I'll let you 1 minute again. So once again, if we go through the documentation for the subtraction, you have the operation, the infix operator, which is minus, which was very traditional. And then after, we can use it for integer, naturals, and tests, and so on, as for the addition, except that we are going to lose some properties in some cases. For example, we can do some n1 minus n2. And here, this one is expected. So line 42 should be solved right now. So we are going to say the same one, n1 minus n2. Okay, this one has been solved. So 46, we have to subtract two naturals. And one important point here, since we do a subtraction between an integer and natural, as for the addition, the result, it's also an integer. The negation for two naturals, so we are going to do it thanks to the minus infix operator once again. But here, what's important is, since we do a subtraction, we cannot, prove that the value is already a natural. So same as the addition, we lose this property, addition, when we decide to add an integer with natural, of course. Here we lose this property. So once you decide to subtract a natural with another one, you have an integer as a result. Okay. So once again, you can execute your test. And you have the last one, which is the subtraction with the test. And this one, you can do it like this. And it's still a test, so you can have a negative balance, okay? And this is normal, so you can have negative balance or positive balance. So you can decide to manipulate negative values for cryptocurrency and positive, okay? And finally, as we can see, we have the integer, naturals, and so on. We deal with here with the first column with constant, the second ones with parameters with types, and then after sometimes we want to do some transfer, to do some casts, to transform from an integer to a natural to an integer. Or vice versa, an integer to a natural. So we need some special operation, and we can do it. So it's a kind of cast, and let you read the documentation to do it, and let you 2 minutes to do it. 1 minute for each should be enough. Sorry, we are learning really step by step. So we at the moment we really see really simple things, but we need this thing for the coming con. So if we don't understand this and we don't know how to write it, we cannot continue. So this is mandatory. Okay, so if we go through the documentation, we see that we have one specific section which explains how to transform or to cast an integer to a nat and back. Okay, so we have two constructions. The first one is a hint, a function which is called hint. We take a naturals and return an integer. You can use also the addition, as we can see before. And for the second one, in fact, we choose the absolute. So it removes the negative part. So it just sends you the value and transform. If it's a negative integer, it sends you a positive one. If it's positive, it's still it's an identity function. So this is one capability to transform an integer to a natural. So this one could be done like this, int of 1 and 1. And of course, I forget the semicolon. Okay, and the last one, the capabilities to, in fact, remove the negative property, just returning always the positive part, the positive value as a positive value. Okay, and it's done. So just go back to the documentation. Here, if we have apps of -1, it's still okay. So we can, for example, if we can decide to how to say multiply by -1, it's still the same one. Okay, so we lose the fact here. We don't check if we do some abs of -1, it returns 1. So we are not able to see if it's really a natural or not. It's really a cast. It's really a transformation. If you really want to test it before, if you want to test the integer and to be sure that this integer could be to be cast in a natural without losing without losing this negative property, just to prevent transformation of negative value, you have to use this one, which is not. And as I mentioned just before, here it just lets you return a value, which is a not, or maybe nothing, which is an option, which is a question mark in TypeScript. Okay, so this one should be used if you want to be sure that the integer you receive is it could be cast safely as a natural, and it prevents you to transform a negative value to a positive one. Okay, maybe sometimes you have a negative value, and it could be how to say a strong property which should be verified. So once you retrieve this property, if this one is negative, you can decide to do nothing once this is negative, and you want to transform it to natural, and so on. Okay, so you have this different function which prevents you to transform. It lets you to transform integer to natural and vice versa, but also to let you to transform positive integer into natural and only a positive integer, thanks to the is and not. And this operation is also a native operation in Michelson. This one already exists in Michelson also. Okay, so we do some basic manipulation. So what we're going to do right now is you're going to manipulate some strings. This is the same exercise, but with strings. So here we are going to go through the count number 3. And so we see that the strings are done thanks to this the cuts and the double cuts. So right now we're going to do some operations, some concatenation, string catenation, and so on, string manipulation in order to retrieve the first characters and so on, just thanks to slice operation, as we do in, for example, in JavaScript, and so on, the length and so on. So for this one, once again, you have the documentation. You have the basis, the basic introduction for string and bytes, and you also have documentation for the reference documentation for the API, for the string API. So I'll let you work on this item few minutes. So just to be sure, we are going to do it. We are going to do the 3 exercise in one shot. So don't be shy. Read the documentation and see the documentation is clear enough and so on, and try to apply it. So I'll let you work during. To do like 4 minutes until for me it's 10 a.m. So I guess for you it's what it should be 1. Oh, I don't. How many hours? I don't know in fact. So I let you work to 4 minutes. Yeah, thank you. About 3 minutes. Thank you, Sanke. Okay, so I'm going just to open the documentation first. String bytes, this one. No. Ah. Okay. And the second one, which is this one. Okay. Few seconds. So here we go. So the first one, which is the string concatenation, right? Which is here. So the first I'm going to execute the third one. So third one, which is on line 8. Yes, this one, we have to solve this exercise, which is a concatenation of N1 and N2. So if we go through the LIGO documentation, hopefully we have an infix operator, which is plus, once again, but which deal with string types. So this one should be solved quite easily, just writing this one. So once again, thanks to the what we call the ad hoc polymorphism, we can use this infix operator. So the hello world is here, so it's a success. The second one, so second one here, which is the first character. So I assume that n is never empty string. Okay, we don't have to check it. I know it's not a good practice, but just for the exercise, we assume n is not an empty string. So here for the substring, we have the function sub, and here we see something which is quite new, which is in fact sorry, the capability to use a function, but with a namespace. Here we have kind of namespacing. So some functions, for example, are defined, but in a given namespace. Here, some string is a kind of virtual namespace. And so this lets you, for example, to write sub for another type. Here, we know that this is a sub for dedicated to string. So we're going to use the namespace string in order to select the right function, okay? And if you go through the documentation, the test, here, if you read the function to do, this to do is also, we have a prefix, which is k, which is also a namespace. And if you go upper on the file here, we see where you have a directive, which is an import here. And here we import in the source code a file which is located in the directory command, and the file which is todo.js LIGO. And this one is we import this file and we link this file to a given namespace, which is k. Okay, this one important. So just let you to introduce the capability to import source code. And here, if we write code in Camel LIGO, this is the operation to import every source code. You can import, of course, some piece of code which are written in Camel LIGO and so on. And you have to, how to say, to bound this in a given namespace. You are free. You choose the name you want, and then after you can deal and to call function. So if we go to the command here, we have a function which is just a simple to do, which is a polyphonic one, but which do a fail with, which fails as saying, okay, I would like to fail because something is missing. And this is the functionality of to do is please fail and give you the message which has been given once I write the to do here, which is we should return the first character of n. So just to see that here we have also the capability to have namespacing. Okay, so after saying this, we can solve this problem using the sub function, which takes 3 parameters. And here we see the one important thing, which is we're going to manipulate naturals in order to reduce the risk to do some stupid things. For example, try to access character with negative indexes and so on, which is a nonsense. So here we see that we are going to use natural. Of course, we use indexes which could be higher, so we can have out of bound, of course, but it prevents some kinds of strong wrong manipulation using natural values. So here the first one. The first one is the index, and the second one is the number of characters you want to retrieve. And the result, it's also a string. So here, just to be sure, we are going to string sorry, sub. We are going to extract the first one as natural. We are going to extract one character as nat, of course. And we are going to deal with the string which has been provided as a parameter here. So we can execute it. And then after we have the h, uppercase h, which has been extracted correctly. Okay. Of course, if you omit the as nat, there's no implicit cast. Okay, the compiler don't see that one could be a natural. He complains and say it should be a natural. So you have to use an idiomatic construction to explain that IN is a natural. Okay, this is mandatory. Okay, so we have the length also. So the length is given once again by a given function, which is in the namespace strings once again. So this one is a simple function. It could be simply called string, thanks to the string namespace. Sorry, string with a and length of n. And that's all, finish, okay? So here we have really basic constructions for string, just which is the concatenation, extraction, and the length, and nothing else. You cannot, for example, we have no native capabilities, for example, to parse a string and transform the string to an integer, for example. You know, nothing like this. It's not provided by language right now. So I say right now, I don't know for the future maybe, but right now this is not the case. We are really minimal function and capabilities once you decide to manipulate and to deal with strings. So the core number third has been completed. So we are going to manipulate right now a data type which is dedicated and which is provided by Tezos, which is one important data type, which is bytes. And bytes, just to let you introduce bytes. Bytes is mainly used, for example, once you decide to, for example, to do some serialization. So once you decide to serialize data, values and so on, you can use bytes as an intermediate representation. So you have bytes and so on. So it could be used for serialization and deserialization capabilities. So once again, here we can go through the documentation, and of course we have the bytes also for the manipulation. So for the manipulation, I said that for the serialization, you can use pack and pack. So pack take something which is a quote, so in every object, and return the bytes. And you can unpack also a series data thanks to the bytes, and you have an optional of something. Optional because if you cannot deserialize correctly, it returns nothing. Okay, so you have the object which has been deserialized of nothing is the deserialization cannot be performed correctly. So we are not going to use the pack and unpack today. This is not how to say mandatory. We see how to use it the last day during the game. So I'll let you do it once again. Work on this core 2-3 minutes, and just to see that we have the same capability, the same property as a strings. So I'll let you work during 3 minutes. 3 minutes, yeah. Okay. Hmm. Okay. Okay. A few seconds. Okay, for the bytes, the addition is the concatenation is a little bit different. We don't use the plus and fix operator. We use a dedicated function which is in the bytes namespace. Once again, so we have a dedicated namespace. And I don't mention and I show you how to write bytes. So you can write directly literal for bytes, and this one should be written like this. Using, for example, here it's an ASCII representation, not ASCII, for example, hexadecimal representation. And since it's bytes, you have to use two bytes two values, two hexadecimals in order to have a byte. Okay. So if you try to write bytes with 5 hexadecimals, it's rejected by the compiler and so on. So here we're going to use the add here, which is called concat. So we are going just to use bytes.concat with N1 and N2. Not the fourth one. Okay, so it's perfect. I show you that we can also write something stupid like this. And here, okay, the compiler complains saying it's the value cannot be parsed correctly. So you can write like this. Oh, it's a 0, not a O. So sorry, I do it again. So here I mentioned that the value before the comma is not correct one. I don't know if the message is clear enough. And you can write it like this. Okay. Yes. Of course, it's an error because of the value I sent. So you cannot write something like this. It's impossible. Okay, it's rejected by the compiler. So bytes are checked, and the construction, this construction is it's checked during the compilation. Same for sub. It's the same. In fact, the same construction as strings. So you just have to repeat the same code, just changing the namespace, and that's fine. Yeah, well, we are dealing with the bytes. Okay, so here you just to do some bytes dot sub. Once again, the bytes cannot be empty. This is a strong property, so you can extract immediately the first one. Here you don't have to deal with this property if my bytes are empty. This is impossible by construction. We're going to take the first one. Like once again, here you should deal with naturals and my value, which is bytes, which is by as a parameter. And of course, I forget the semicolon. So here, once again, and here we can see that the bytes is construction with 2 hexadecimals. Okay, so if you decide to count the number of hexadecimals, you will have 2, but 2 are necessary to build the bytes. And the length. So here we're going to just same as string, but in the namespace bytes, we're going to deal with the length thanks to the function length, and that's fine. Okay. And we can go through the test just to finally show you that here the test use this byte, which is 1, 2, 3, 4, 5, 6, and here the number of bytes is really 3. It's not 6, but 3. The number of hexadecimals is 6, but the number of bytes is 3. Okay, so by construction, and that's all. So we have basic. So we don't see the pack and unpack, the capability to serialize and deserialize. We see it later. But mainly for the bytes, you have the basic construction, which is concatenation, extraction, the number of bytes, and you have also a capability to have some pack and unpack. And that's all. This is you cannot do more once you have bytes as data types. Okay. The most important features is this one, is the capability to serialize and deserialize. Serialization is how to say, is provided directly by the framework, so it's free. You don't have to write it. It's free. So we see the different capabilities. Now, what we're going to see is some basic construction like conditional and so on in the language. So we are going to do this thanks to the K5 coans file. So I'm just going to be sure that everything is broken. That's right. So here, I introduce A and B as the constants, which are true and false. And then after, just to let you how to express the false, okay, because we see the true but not the false. And right now we are going just to first do some comparison to see how we are going to compare some values. So we are going to compare strings, Boolean, and so on. Do some the comparison with the end operators, the or and so on. And then after, you're going to see how to do some selection with the if then else construction, with the geometric one. And in order to do this, we already have a documentation entry, which is this one. And here, once again, I let you read the documentation and try to play with and solve the small exercises, which are also still really simple one. So I'll let you work during 3 minutes. Okay, 1 minute. So the complexity will increase soon. So this is, I think, the last set of exercise which are quite simple. The next one is much more complex. We're going to talk about functions. Okay. Okay. So the comparison, if we go to the documentation, we have so different operation. We have the logical AND, logical OR, the negation, so the negation with logical NOT, the equality, the fact that which is not equal. So this is quite natural. We have the same convention than TypeScript and so on. So we don't create something different. Greater, less than, and so on. So we have different of this operation is all this one are in fix except the logical none, which is should be it's a prefix. Okay, as usual. So this one could be solved quite easily. So I'm going just to write this code like this and show you something which is complaining. Of course, we are doing the K5, yes. So you can write this one like S1 equal S2. And what you can see here, the difference between the capability here I just write in the previous example, once I write the function, I write just one expression, which is simple one. Here, I just slightly change the syntax. I decide to open the block here, and I return and I have an expression. And this expression is the same as this one, return S1 equals 2. The same expression. Oops, sorry, this character. Okay, since this one is the last expression, the return is implicit. If you want to return in your code, once you have, for example, branching like if then else, you have to use return. So you can write S1 equal S2 or return S1 equal S2. So when I write some block like this, I use the return. Because I think it's much more simpler to understand. I think this is my personal view. The Boolean one, of course, is the same. So here we have a block also. So I'm going to use the return instruction, and this one is B1 and B2. So we have a bunch of tests which are a success because I do a lot of tests with the AND and the OR. So you can go through the test if you want to see. You have the OR, so return B1 or B2. Of course, this is quite natural. And finally, we have the conditional. So here, for the condition, I would like to use let you use the if then else, and for each branch, you return the string corresponding or the comparison, which is a success. For example, if you write if I1 is less than I2, I return the string I1 less than I2. So I let you work in this one. I don't know if you're done. Okay, if it's done. Okay, I can write the solution. So if what is expected here is something like this. So if I1 is less than I2, then I open the block and I return the string which is expected just with this one. Else, so we have the else if construction, of course. If I1 is equal to I2, I return my string, which is the I1 equal I2. Okay. And finally, else, this is the last case, I do a return. I'm lazy, I do some copy paste. A2, and of course I have to remove this sentence, this expression, sorry. And once again, the core is finished. So here we see that we have a traditional if then else and so on. And of course, if you forget this else, one important thing is the type checker is going to prevent you that something is missing. You say, okay, you say we're expecting a string here, which is the return type which is expected, but I got unit. You got unit because here you return a string, okay? Here you return a string, but you say that at in the sentence we are the else here is implicitly this one, else return unit. Okay, I don't know if I guess it's like this. I don't know if unit, no, it's unit. I don't remember the syntax for unit, something like this, I guess. Yes, it's a unit with a minus a lowercase u. So if you forget this one, the else, if the compiler consider that you are writing this kind of code, which is else return unit. So it tries to then after to type check, and here you see that it's a type unit, and here's a string and a string, which is not compatible. And of course, you are waiting for a string. So you say it says that unit is not the good type. It is not the expected one because you are waiting for a string. So here you have to write a complete if then else instruction if you want to have a complete code which is type checked correctly. Okay, this is important also. And of course, you cannot return something which is stupid, like one, and of course, you're going to complain you are merging string and int. This is not mandatory. This is not expected once again. So this ends the first important stage here in the core. So right now we are going through much more complex concepts like function, tuple, records, variant types, and so on. So we're going to start with function. So just to recap you, I'm trying to set up here my make command. So to do a short recap, during the first one, we see that we're able to write constants and the function like this. So we mix the expression of the parameter and the type which are expected. So here, when we write add, well, we say that the add the binding add is binded to with the equal here operator is binding to this expression, which is a function. And this expression says, I'm waiting for two parameters. The first one is a, which should be an integer, b should be an integer, and this function should return an integer. And the body of this function is this expression, or it should be a block, as we see just before, which is a plus b, okay? And this syntax here, this whole syntax here, it's also an expression, okay? It's a function, but it's also an expression. This is important because you manipulate function. This is what we call a first-class citizen. An expression, a function, it's also an expression. Same as JavaScript also. So you have some capabilities to manipulate functions via another one. So you can, for example, go through function and send back as a parameter function and so on and manipulate it later. This is an important feature. We have also another syntax, which is this one, but we prefer and we would like to force people to use this one. This is This syntax is based on a concept which is called deconstruction. We should see it later, but we prefer to have this syntax because this syntax is much more, how to say, idiomatic and near to the syntax which is provided by JavaScript, so typeface and so on, not this one. Okay, so one important thing here, add, it's a value which it's a binding, it's a name which is bind to an expression which is a function. So a function, it's an expression. Okay, so I let you, for example, here first try to write the body. This is a really simple one. Okay, which this one is write the function which is max, which return the maximum of 2 integers, just to finish and complete our how to say skills in manipulating if then else and so on. How to see also how to write correctly a body of the function, and then after we are going to see something which is quite different, which is capability to do a function which returns another one and so on, and to manipulate function as a first-class citizen in the language. So I'll let you work on this first one just 1 minute, and I'll let you work on this one just after an explanation. So please do just the max, and then after we are going to do the concat and explain what we're expected to, we're waiting for. Okay, don't do it this example, or except if you are fluent, you can do it, but try to do this one first. It should be really simple one, and then after we're going to this one. Okay, so I'll let you work just 1 minute for max. It's max is quite easy to do it. We already have all the capability, and we see all the syntax construction to do it quite easily. Okay, 1 minute. Oops, sorry. Okay, done. Okay, so this one should be solved quite easily. So I'm going to use the is and else construction, conditional instruction. So this one can be written quite easily, which is if, so we already see this construction just before, A is less than B, so return the max, so return B. And otherwise, we return A. Oh. And that's all, return. Okay. And I add a block like this. And don't forget the semicolon here, otherwise your compiler complain. So can still okay, so the max is okay. So right now we are going to write a function which waits for a string and return a function which is waiting also for another string. And this second function should do a concatenation of both string. Okay. So for instance, once I write concat of A, it returns a function, and this function can be applied with another string. And then after, once we apply concat A to B, I should have a result which is the string AB. Okay, the concatenation of A and B. So we know how to concatenate string, we know how to write the function, but we don't know how to write a function which returns another one. Okay, so if we go through the type here, we can see the type is a little bit different. Concat is the binding, so we are waiting for an expression which take first a parameter, which is a string, and as a result, and this is really important here, as a result, we are waiting for a string. Oh, sorry, we are waiting for a function which waits for parameter, which is with string, and which should return a string. Okay, so concat should return a function which capture A and which return a string which concatenate A which has been captured and return a function which we're going to concatenate the parameters we think we are waiting for, the second one, and concatenate the capture of A with the second parameter we're waiting for. Okay, so we should return a function here. We are waiting for a function here. So here we should return an expression which would be a function. So I let you work on this and try to understand how to do it. You have some entry point here, which has a LIGO basic also for the function, which has here. And you have some explanation also for how to define a function, how to write function, and how to write here what we call anonymous function. Okay. This is what we call lambda or closure in other function. This is this lambda, the capability to what we call capture some variables, some values, sorry, and we have what we call activation frame. So activation frame, you have a function with some values which have been captured and can use in this function, in the function itself. But we're going to see it once we write the solution. So I'll let you work on this item because it's not so easy. This one is not so easy. So I'll let you work, how to say, 3 or 4 minutes just for this one. To be honest, it's one of the most difficult parts of the Quran here. You have 2 difficult parts, which is the function manipulation of function, and the part 9, which is dedicated to the variant types. Otherwise, it's quite simple. The rest is really simple. So I'll let you work. So I say 4 minutes. Yeah, we have enough time. We still have 1 hour and 20 minutes. And I hope this workshop is helpful, because I saw that some people left the meeting, so I'm a little bit upset. So I hope it's helpful. Thank you. Thank you so much. So till 42. Oh, done. Perfect.
Didier,
Yes,
are we done with the workshop?
not yet.
Okay. Can we just know how much more longer so that I can mention the same?
We have still 1 hour and 20 minutes because
Another
it's a workshop it's a 3 hours workshop. It's
Understood.
really long. Yes.
Understood. Yes, understood. So
Yes.
those who
Yeah.
have joined us, thank you so much for being here. I see a lot of them have left. I'm sure.
Yes, maybe they have to go back work, I guess, something like this.
Yeah, of course, yes.
Yeah.
So another 1 hour, 20 more minutes. And those of you who are actually in a hurry or have to go, this will be uploaded on the Tezos India YouTube. But I would really appreciate, and Didier as well would really appreciate if you stay on. And thank you so much. And again, the questions will be addressed to at the end. But when Didier does have time, he will address it as well.
Yeah,
Whenever.
of course. Yeah, of course. And we have a Discord channel, so if you have some question, you can ask it thanks to Discord channel and so on. And we are really proactive. You have a really quick responses, really quick responses.
Thank you so much.
And once for whom can attend till the end, you have all the solution and so on. So you can go through the solution and so on and so on. So you can solve it thanks to documentation and so on. And once again, if you have some question, you can do it even after this event. Okay. Thank you very much. 1 minute left. Okay, so we are going just to solve this one. Oh, sorry, wrong manipulation on my side. Okay, perfect. Sorry. So the function. So here, one important thing which should keep in mind is function are expression. So what I can do here, I can define another value here, thanks to the constant. I'm going to call it do concat, okay? And you should remember, I explained you that here it's a binding. You bind a function to a value. So we can do it also in this block. We can do the same. So here we can do write a concat, and you can say I'm waiting for a string which is b. I return a string, and the body of the string, and we know how to do a concat, is simply a plus b. And one important thing here, this function, this expression, use a parameter which is b here, but also capture another one which is a, which is given by the first function, which is concat, which is a function which let us build another one. Okay, so we are, frankly speaking, we are building expression which are function. It's a kind of building the code. If you like, you building your own code directly. So here, the most important thing you should keep in mind here. This one, this construction is the same one as this one here for the const. Sorry, is the same syntax, except you do it in a given block. Okay, so the do concat here has a local definition. So it means that you cannot call do concat directly outside the block. Okay, the local scope is dedicated to the scope, which is starting here and ending here. So once I wrote this function, I can do and can work with it, but you cannot call it do concat outside. It's impossible because it's a local function, and this local function requires the parameters which is captured, which is a. Okay, this is really, really, really important. Then after, once we do this, what we can and you return do concat, and that's finished. It's finished. That's fine. So we can do it quite simpler, directly returning my function. Okay, so I prefer to let you write this one like this because you have it's a symmetry. You retrieve the same syntax as the one which is used to define the top level function. So you keep in mind that you can write local function and so on in your block, and you can use it. And since you can use it, you can return it. Okay, so here, do concat, escape the scope here, which is here. And thanks to the garbage collection, the do concat can be used outside. And once you return do concat, you return it with the A which has been captured. Okay, this is very important. And this is what we call a closure. So if you learn languages like, I don't know, Scala, Java, Haskell, and so on, and if you're reading something about closure, the closure is just this thing. It's a function which has been defined with a variable which has been captured in the upper layer in the scope, which is the upper scope. Okay, so here A came from the parameter. Of course, I can define something like this. We can define const C equal blah blah, and you can also, for example, do plus C. So you can also decide to define some variables in your blocks, capture these variables, and escape everything thanks to the return. So do concat return the variable, return the function, but this function is strongly linked with the context, which is A and C. Okay, so you don't have to care about the scope of C here. It's captured and it's magic. If you already do this with Perl, for example, in Perl, it does not work. You have to do it by hand. Okay, I don't know if somebody use Perl right now again, because it's really an old language. Okay, and that's fine. So my do concat is written and it's done. So I just have my A and B, which has been concatenated. Okay, so here we write just a simple function, and we return it as usual. Okay, there's no specific syntax. Only one specific syntax for types. Here we use this character just to mention the return type, and here we use the fat arrow for the types itself, which is the function types. Okay. Okay, so this is yes. So I can show you the test, which call this one. Okay, here I call, so the concat, which is, so I open K6 function Js LIGO in the namespace core, okay? And the case, which is, I'm going to call the concat function we just have defined here, which is in the namespace core, and I apply it to A, and then after I apply it to B. And as a result, I have a concatenation of A and B. That's all, finish. So you have the capability to write some function, some portion of code, and to provide it later for a later deferred, for example, final computation. Okay. So instead of writing function with two parameters, write a function which take a parameters, which returns another one which take another parameters, and return the results. Okay. So we are going to see it later, this is what we call purification and but I think it's the most difficult part. Okay, so here we see something which is the capability to build a function and return a function as a result. The next example is the capability to have a function as a parameters and apply it on a given parameter. Okay, so what I'm waiting for here is the capability to handle a function. What the handle do is waiting for a function here. So I'm waiting for a function with waiting for a parameter, which is a string, and return a string. And we're waiting for a second parameter, which is a string. And what we'd like to do here is just to apply the function f to the parameter a. Okay, simple. So here we see what we call, this is what we call high order function. High order function is a function which takes a function as a parameter or return a function. Okay, so you have two kinds of high order function, the one which are waiting for string and the one which returns strings. One which is waiting for a function, and there's a one which is returning a function. So and you can, of course, mix both. So here the handle should apply a function which has been given as a parameter and to a parameter. And we can see also how this one is called. I use the traditional construction we already saw before, which is I define a function with a parameter b, a string, and I concatenate b with a string which is a. Okay, donc simple. So I'll let you work on this second function, which take a function right now, and I'll let you work each 61, 4 minutes. We have an hour and 10 minutes. A minute left. Okay, so we can solve this one. So in fact, the code for this one is really simple because we just would like to apply the function f to a. So there's only one solution, which is I return, and we know how to apply a function. This is syntax, which is f and a. That's all. So you decide to apply f to a. But what's important thing is f is a parameter which has been passed here, and a the parameter which has been passed here. Okay, so the application which is here we use a variable which is a function. Okay, and of course if we do some and I forget something, no, it's okay. We have a success again with AB. What is missing is the number of the line. So we have an optional section. I think we are going to go through the different types we can build with Js LIGO, and if we can, if we have time, we are going to we go back to function in order to solve this one because it's a little bit difficult and it takes too many time. Once I do it to Tezos Israel, it takes around 20 minutes, and I think we should go through tuple, records, variance, and so on, instead of this optional section. This is just an exercise, and if we have enough time, I will go back to this section. Okay, so we have a do optional part, which is true. So the test. False. So I don't want to do the optional part, and that's fine. Sorry. Fine, the tests are okay. So we do it later. Okay, so right now we are going to introduce some specific type construction. The first one, which is the tuple, okay. A tuple lets you construct data types which are pair, triplets, and so on. You can aggregate, so you can gather different values of different types in only one structure, okay. And this one is done thanks to a square bracket. And for instance, if you want to define a point, which is 2 integer, you define with a square bracket and you write integer, int, comma, int, and square bracket. So here you just specify a type. So here, this is a new construction which is introduced. We define a new type, which is point, in order to have, how to say, a much more expressive type definition. I can use this type directly, but here I prefer to use point in order to have a much more, how to say, expressive layer and an expressive way to define values and so on. So here, what I would like to do is to define a new point. We have a function which takes 2 parameters, which is the abscissa and the ordinate. And I would like to have a point as a return. And point and take should be a pair with 2 integers. The same, I would like to return the abscissa. So we can build tuples. We can also access the different values which are in this tuple. So we are going to see how to do it. And this all this is explained in this section. So once again, we'll go through the documentation, which explains what a tuple is and how it works. Okay. So here we just have a definition of a full name, for example, with first and last name. And here we have the construction. And then after we have also the deconstruction, which can be done in different style. Okay, we are going to see how to do it with different style. Okay, so I'll let you work on this item. For the new point, abscissa and ordinate, I'll let you work during 4 minutes, I guess. And one important thing here, we introduce a new capability to build a type, which gather native type, for example, in order to have a much more complex one. But of course, you can gather and you can build another one thanks to the point and so on and so on. The complexity can be increased. And what we see also is the capability to define our own type. So we define type, which is a point here. And we can also reuse this type in order to have expressive type signature here and here. So here we see that we would like to have point as a return, and here abscissa just manipulate point. Same for ordinate. Okay, so the type aliasing is really important here in order to express and to have expressive type definition text signature. So I let you work during 4 minutes, 3-4 minutes. And of course, one important remark here, you can gather int with a string, with Tez and so on. It's not monomorphic, okay? It's not like a list and so on. It's really a tuple, okay? So it's string, Tez and so on. You can mix different data types in this one, okay? This is also important. This is why my example maybe is not much. It should be improved. For the tuple improve. 1 minute left. Okay, so the first one, which is a new point. So if you go through the documentation, in order to build the tuple is the same as the one which you use for the type, but except that we have to put expression instead of types. But the whole structure is the same one. So this one should be simple. You just have to return. And then after, abscissa ordinate here. And that's all. Okay. And it's finished. So I can execute my 7. Okay, so if you see the truss here, sometimes you have what we call a pretty printing, and the pretty printing ones, how to say, the code can be written in different syntaxes. The one which has been chosen, I guess, is the one which is a camel LIGO for the expression here. Okay, so don't be upset by this. We should see if we can retrieve the same syntax as the one which has been used, for example, for the test. But it's difficult because if the code has been written in Js LIGO and the test in camel LIGO, which syntax should be used for the pretty printing? It's a nightmare. This is one important. This is a nightmare for us. So don't be upset. The syntax chosen for the externalization and the pretty printing is it's a camel LIGO one. Okay, so here we use the square brackets for the construction, and for the abscissa we have different manner. You have the first one, which is quite simple. It's what we call projection function. We have a P, and we are going to access the data, which is the value which has the index 0. Okay, so this is one solution, and we have a second one, which is a kind of deconstruction. I let you show. You can write this one. So if you go back in the documentation, which is this one, I guess, yes, you can write something like this. Okay, and here the values, we introduce different values at the same time thanks to deconstruction. And deconstruction use the same structure with the straight brackets. And here you have x, y, which is in fact the deconstruction of point. And then we return the second, which is the ordinate. Okay, I hope it compiles. Where point not found. Of course, it's P. Sorry, point in my type. Okay, and it should complain, but I suppose that you should also put this character in order to prevent. We don't have a warning. So this is a deconstruction. And if you see also in the documentation, you have the let construction. We are going to see later why you have a const and the let. In the let, okay? There's the difference between each one. So here we have different aspects. This is a capability to create a tuple, okay? Of course, you can have a type tuple of tuple and so on, and you can print types and so on, as I explained just before. This is a capability to build a tuple, which is quite simple. This is a capability, one possibility to retrieve one information. So this one should be used when you want to, for example, to retrieve only one. But if you want to retrieve different values at the same time in the same instruction, you can use this construction, this construction expression. With the left value, you can introduce different values at the same time. So here we define a binding with x with the abscissa coordinate, thanks to the deconstruction of p with the syntax using, once again, square bracket. And then after we return the second parameter, which is the second value, which is the ordinate, which is the one which is expected. Okay, so we have this different aspects. And that's all for the tuple. So here we have the capability to aggregate and to gather different values in just one structure. If we think about, go back to the function here and show you we have different, in fact, syntax. In fact, the syntax, the second one, in fact, use tuples, because one you call the add, in fact, here behind the scene, we send and we have a tuple which is built, okay? So this syntax, in fact, hides the capability to do the deconstruction of the tuple when this one explain it, do it explicitly, okay? So it's quite logical, okay? So the logic here is a tuple deconstruction when in this syntax, the tuple deconstruction is completely hidden and is done by the compiler do it for you, okay? This one important. This is why you have different syntaxes. So back to the tuple, I think we are finished. And we are going to right now to go through what we call the records. And the records, if you are already aware and of the JavaScript syntax, is the same as the record which are provided by JavaScript. So this one, it should be simple. So once again, we can define types, and the construction for the records, it's a little bit. It's much more complex. So you have to use square bracket. You have to use brackets. Okay. And for each value you want to capture, you have to give an attributes. Okay. So the attributes help us and give more semantics. If you go back to the tuple here int, you know the first one is an abscissa because you explain it in the function. Okay, it's not given by the type. The type here we have a two integer, but you don't know what it is. It's a point, but maybe you can reverse and say, okay, the first one is abscissa, the second one the ordinate, because I want to do it like this. So here the fact that int is the abscissa is given by the function abscissa itself. So the semantics is hidden in the code. Okay. With the record, we can give much more information and we can give richer semantic thanks to the type. So here we can define an icon data with, for example, a balance which is Tez, with Tez value. And we can also count the number of transactions which has been done, which is a natural. And then after we have something which is much more complex, which is a record with two attributes, the one which is related to the balance and the one which is related to the transaction. So then after, if we go back to the point, we can define the same one with instead of a tuple, instead of defining a tuple, you can define something like this. And here you explain explicitly, you explain who is the abscissa and who is the ordinate. But if you write this like this, you have to revisit, of course, the way to construct the point, the way to write the abscissa and the ordinate, and so on and so on. Okay. So if you decide to write it like this, you have also to revisit and to review all your code. because the construction is the same one. So back to the record type. Here, what we're going to do is the same as for the tuple. We are going to create a new account data. We are going to and to access the balance. So the way to access the balance is can be done directly calling the balance attributes with the balance name, which is here, with the field. Okay, so we extract exactly the field thanks to its name. So the field balance once we have account. And then after we're going to see how to do the modification of an account, because as I explained, LIGO, it's a pure function, it's a language without effects. So we cannot define record with side effects and so on, saying, I would like to just modify the balance. We should have a given pattern in order to do it. So this is why you are going to do this in the modify account here. So I'll let you work on these two small functions, and I'll let you 4 minutes to do it. And once again, you have documentation here which explain the map record and so on, and explain how to do the modification here on a given record. What time is it? Okay. For those who already have some experiment with functional languages, tuple are called, in fact, the product type. This is what we call product type. The tuple, not the record. Okay. Left. Sorry. I'm going to also download the page, document page. You have two again. The first one is this one, if you remember. Yeah. Okay, it's enough. Okay, so the construction can be done quite easily. It follows the same syntax, but except of manipulate types, we're going to manipulate values. So we are watching return. And here, one important thing is the order is not important. In tuple, it's important, of course, but here it's not important because we have fields. So we can define, for example, transaction. So, oh, sorry, we are waiting for how many transactions? Just to be sure, we have a balance of 5 days and 3 transactions. Okay. So transactions, so we are waiting for 3 as NAT. And then after, we can just return a balance with 5 as Tez. That's all. Finish. Ah, I'm sorry, I forgot something. Oh, sorry, it's not a, it's not a, yes, something, syntax is not good one. Okay. Okay, so as you can see, the order is not important. I think you can set up also here. This one here is still it's still okay, and of course you can change the order. It's the same one. Don't change the semantic. Okay, so you don't have to follow the order. This is not important. It's like a map. Okay. Then after, so we can see that for the account you have just to access the field balance. One important remark here, the parentheses are important because the compiler is waiting for an expression, and since the expression it should be in fact guarded by the parentheses. So if you have something like this, it says that the line 24 something is broken. The dot here is not one character which is accepted. So you have to prevent it, just to say, okay, this one is my expression, and I would like to access balance from this expression. So this important point. This is really specific to Js LIGO. Okay, so sometimes it takes time. I don't know why. Okay. Okay, we have the first test, which is okay here. So once, what we would like now is we'd like to modify our account, and then here we are going to see something which is typical in JavaScript and TypeScript, which is idiomatic, which is the capability to to do a copy and modify update an object, but with a shallow copy. So it's not a side effect, but it's just a shallow copy. Okay. So this one is done thanks to this construction, which is explained here with the ... and your record. And then after, you just have to specify the value you want to update. Okay. So here, what we would like to do is just I don't remember the sentence, which is I would like to return an account with 5 transactions. Okay. So what I'm going to do is just what I would like to, I'm going to update my account, but the transaction right now are 5 and no more 3 as that. And one important thing here, it's not a modification of the account which is here. It's really a shallow copy. Okay, so we have a copy. This is a new record where a transaction has been set to 5 as not. Okay, so this one is not modified, so you can use it and modify as usual, and you don't have to think about side effects. There's no side effect. Okay, and this is how we do some kind of mutation in the code. Once you want to do some operation in your storage and you want to update the storage, you have to do this kind of operation thanks to shallow copy, data structure shallow copy, and just updating, slightly updating the fields you want to update and nothing else. So here, we retrieve all the information from account except transaction, which is overridden, and you update it. Okay. So one important thing: shallow copy and no side effect. I think we have side effect in SmartPy, and in LIGO we decide to do no side effect because it's much more simpler to understand. You don't have to think about process and other function which can modify it behind the scene and so on. Here we have you have your data value, your simple value, which is your account, and you can manipulate. And you can trust it, and you can manipulate without fearing modification which has been done behind the scene by another one, and so on and so on. Okay, so and you return a new account. Okay, this is what I would like to say about the records. So there's no deconstruction of records in Js LIGO. The deconstruction already exists in Camel LIGO and Pascal LIGO, I guess, but not in Js LIGO. The deconstruction is not yet done, and we don't know if we are going to do it. Okay, so we see different capabilities to build types and build data types, data which could be complex. We saw the tuple, we'll see the record. And right now we are going to see something which is really different and which is only available, for example, in TypeScript or languages like Camel or Haskell and so on, which is called the variant type. So what a variant type is? The variant type is, it's a type which offers different, how to say, different cases. For example, it can define a type which is play, and the play could be, it's like the basic one, basic, for example, variant type could be an enumeration. Enumeration is a type which could have different values, and exclusive one, okay? So here, for example, I can define a type which is play with three possible values. The first one, which is paper, scissor, or stone. So this is the syntax in Js LIGO. It's quite curious. I agree. But this is how to express a constructor or a construction, which is square brackets. So it looks like a tuple, but since we're defining a types, if you are using a string, which is an expression in your types here, for us, it's construction where you are building a constructor, okay? And this constructor, you can have a disjunction, disjunction of different constructor. And if you gather all this constructor, you have what we call a variant type, okay? So once you define this type, you have three constructor, which is paper with no parameter, because paper is just paper, scissor, and stone. And once you build a paper, you have a play type. When you build a scissor, you have a play type. And once you build a stone, you have a play type. Okay. So based on this, I define a type, which is coin. And the coin is could have two states when you look at the coin, which should be heads or tails. So if what we like to do is first build a function. So this is just to highlight and to express the usage of the constructor, nothing else, okay? And so I would like to build the smart constructors, what we call smart constructors here, which have the capability to build a new head, and the one which has the capability to build a new tail, okay? So it's a really simple one. This is just the smart constructor, the constructor, basic constructor that we provided, the usage of this constructor. Then after, we are going to see the pattern matching. The pattern matching is the capability to have a match, which is a switch case. And the matcher is going to, how to say, to trigger the right expression thanks to the data we are manipulating. So for example, if you want to check if you're playing, for example, paper, you have to do a match, which is a capability. This is the idiomatic way to do it. The match take an expression, and if an expression should be a variant, and then after you have to provide a record here with, for each entry, for each field should mimic, in fact, the name of the constructor, which are paper, scissor, and stone. And then after, once you retrieve and you filter the name of the constructor, you have to provide a function which explains what to do with the value, this value. And the first parameter here are the parameter which has been provided with paper, scissor, and stone. In this case, paper, scissor, and stone has no parameter. So here, this is why the function has no parameter. And if you remember, this expression, it's a function. So you just have to function. This is why function manipulation is important. This is why I talk about this, because here we are manipulating function here. Okay, so here, just to write a function which take a play and say if it's a paper or not, you just have to say, if it's a paper, I return true. So it's a function which takes nothing and return true. If it says scissor, it's a function which takes nothing and return false. And same for stone, it's something which takes nothing and which return false. And then after, thanks to the pattern matching, we return the predicate, establishing if your play is a paper or not. And of course, since it's an expression, you can do a return in this case here. Okay, so the match is an expression. So Saying this, I would like you to write first the two usage of the basic constructor which I provided once you define your variant type. And then after, we are going to write a flip action, which is if I have a tails, I would like to return a heads, and if I have heads, I return the tails, nothing else. Okay, thanks to the and vice versa. And so we are going to do it thanks to the pattern matching we introduced just before. And then after, we are going to see things which are much more complex. Okay, so I'll let you work on this item during 4 minutes. So after the variant types, the rest for option, list, map, set, and so on, it's much more based on API. So it's not complex. It's just reading the API and applying like we do, the same. We do the same for string and byte. So if we don't do it, it's not a big problem. It's just a matter of documentation. The most important part here should be understood. It's the function and the capability to build tuple, record, and variant. This is really important, and we are going to see why the variants are so important tomorrow. So I say, yeah, I forget to execute the test, of course. So the variant. Okay. I'll be back in 1 minute, sorry. sorry. So, so we can solve this sort of exercises. So as we mentioned just before, here it is. I'm sorry. Okay. Did you hear me? I hope. Okay, so here it's just okay. Thank you, because Siri has been activated on my Mac and okay. Sorry for that. So here it's really simple. You just have to call the constructor which has been provided for free once you decide to define a variant type. So here we are waiting for heads. So you just have to return heads, and that's fine. That's all. So so here we can write like this because there are no block. It's just an expression. And same for here for tails. Okay, nothing else. Okay. Of course, we can go through the example here, and we see that we are pure equality. We do some inequality. So we have capability also to have the equals operation on some on these constructors. Okay. So back to the variants here. So as for the play and this paper, we are going to do flip coin, and the flip coin is just a simple match here. So I'm going to just match. I'm going to match C, which is my expression, and I have two possibilities. And after I'm going to show you something, and I'm going to ask you a question. So we have two possibilities. The first one is heads. The order is not important also. Heads has no parameter. And if I have heads, I would like to return the flipped, which is the tails. So I'm going to call the new tails just to show it. So I'm going to build a function. So we use it. And here I have tails, I have no parameter, of course, and we have a new heads. Okay. And go. Okay, that's fine. So one question, we can replace this one by another one. Did you have any idea? And is it a good idea? Yes. Which one? So you can use the is and else, okay? But I'm going to show you why using this and else in this case is not a good idea, okay? So instead of writing this expression, you can write like this, okay? If C equal, for example, heads, return tails, else, and then here we are trapped. What we could do, we can say, okay, I return heads, okay. So this is not a good idea, because if we define, for example, instead of playing with a coin, we decide to play with a dice. We define a third state, which is head, tails, and I don't know how to call it in English. Here, you don't cover all the cases because it's implicit. Yeah, you cover a case which is implicit here. So this one is not a good one because how to say, you have no capability, compiler have no capability to say your code is incomplete or not, it's not complete. In the other side, if you use the pattern matching, you have one capability which is really important, really smart with this the match operation here. If you forget, for example, if you decide to enrich your data type, for example, saying I have head, tails, and something different, I say foo, okay. This is just for the example. And you write the code like this, okay, and you will recompile the code. One important thing is here, you say line 66, the pattern matching is an anomaly. You have an anomaly. Something is redundant or non-exhaustive. So the code here says that you're missing something. You don't define the case which is related to foo. This is what we call exhaustiveness of the pattern matching. So if you want to be sure, you have to define here foo. Okay. And I return. I don't care. I don't need to return foo. Okay. And this one is important because here you can recompile it, and that's fine. Okay. So I have to write the code for foo. So you should provide an entry point for each variant type, each variant definition, and this is really important for the security and the safety of your code. You don't have some branch which are, for example, sometimes you have to do some if and the else you say, okay, fail with this case is impossible. And one day, the fail with impossible should be raised and break the code. And as you know, the code you write, it's a contract. And once the contract has been originated, it's finished. You cannot modify it. You have to write a new one. You have to modify it and originate a new one, and think about how to retrieve the storage to set up the new storage and so on. This is a nightmare. So you should use the ifs and else really when you are building simple things, but when you are using a variant type, the pattern matching is really it's the idiomatic way to do it in order to have the most secure code once you do the compilation. Okay. And of course, if I decide to remove the foo here, it's going to complain saying, oh, you are using something which is not different. Okay, you say, okay, you have a sum type variant, or say it's also called a sum type. We have heads from units, tails for units, but we have nothing about the foo. So you say, okay, I have to remove the foo. That's fine for me. Finish. Okay, so really important, pattern matching exhaustiveness helps you to increase the quality of your code. This is really, really, really important. So here we define variants which look like enumerations, but we can define also variants with values, which are how to say, capture values. For example, we can define a point with the coordinate representation with an abscissa ordinate, or with a polar representation with the radius and the angle. Okay, and both representation define a point. Okay. It's the same, so except that the computation should be different. Okay, so here the way to do the pattern matching here is a little bit different. Instead of having this zero parameters, here we capture the parameters which is C and P. C for the coordinate, and here C as a type coordinate and P as a type of polar. And if you define multiple values here, it's a tuple. So you retrieve the tuple which is embedded in each constructor. Okay. So based on this, what we are going to do, we are going to do something which is a little different. We are going to play. And we have defined based on the coin and the heads and tail, we're going to define a type which is turn, which is what I'm going to do, which can be I would like to play or I would like to reset. Okay, and that's all. We don't care about what the reset is and so on. So we define a game. In this game, we count the number of heads and the number of tails. Okay, we define a function type. Okay, so here we gather all the knowledge all the things we see today. We define a flip function which take a unit, so just a unit, and return a new coin. This is just a random function. We don't care about the implementation. This is given by the. And here we define function play, which take a turn. So the turn, which should be a play or reset, a game. And thanks to the turn and the game, what we would like to reflect the number of heads and tails which have been done once we do a flip, and return a new game once you do a reset. And here we mix everything we saw before. And I think then after we just finish this course, because we can go through the much more complex example and see that this is the basis. This is the basis and the way we do, in fact, contract in LIGO at the end. We have some parameters, and parameters have different values, so it's a variant. And then after we send the storage. So here we can see that the turn could be seen as a parameter, the game of the storage. So we have the same. It looks like a kind of contract. We have no operation, but it looks like a contract. The code is not complex. So I let you work during. Allez, let's say 6 minutes, 6 minutes, 5 minutes. It's just a mix of everything we saw just before. And then after it's finished. And I really thank you to be very patient with me and during this presentation. And just to prevent of 8 or 10 minutes for question if you have question. So I'll let you work. Yes, exactly. In Rust, the pattern matching in Rust, it could be also a deep pattern matching. Here, it's a simple one. You just have a selection on the name of the constructor. In Rust, it could be a deep construction. If you have different data types which has been included, you can go deeper. This is not the case in Js LIGO. And you have the same pattern matching in Camel LIGO, which we have what we call deep pattern matching, the same as OCaml, the same as Haskell or Scala, Java right now, with the last version of Java, Kotlin, Swift also, basic modern language with a functional style, or pure functional programming language provides such capabilities also to have a kind of deconstruction. This is what we call deconstruction, or what we call also inductive computation. Inductive because we go through the different values and we extract the values and we use the values which are embedded in each constructor. Yeah. Fine. Mm, 3 minutes, yeah. Just let me check something. I don't know. I think we can do. Yeah, we have to specify unit. Yeah. Okay. So 2 minutes left. 1 minute. General Tezos question: can you use OKML for smart contracts? No, OKML is used for the implementation of the LIGO compiler, but smart contracts are written in. Did you mean OKML syntax, the OKML LIGO syntax, or just OKML, only OKML? Not just OKML, no. We don't have this capability. For example, there's some attempt to use camel and then after to compile it to LIGO and then after to compile it to Michelson. So yeah, no, it's a nightmare. So it looked like a Frankenstein idea. No, we don't use the OKML directly to build smart contracts. We don't do it. We don't do it. Yes, of course, everything has been written in OKML, right? Yes. In fact, once you call APIs and so on, the API are written it's just a FFE, the foreign function interface. They're directly linked to OKML code. Yeah. Yeah. The core is written in OKML. The compiler is written in OKML. Everything is written in OKML, and some parts on Coq. Just for example, the backend, the backend of the compiler of LIGO is written in Coq in order to have some properties and some proof with given lemma and theorem in order to be sure that we have the most optimized code and so on, which is provided by the compiler. This is proven in fact. So we have some parts which are written by Coq. Yeah. And OKML and Coq, but Coq without OKML, there are no Coq. So Coq, because of Coq is written thanks to basics, is written thanks to using OKML. So I'm going just to provide the solution because we are near the end right now. So the play, we have a turn and we have a game. So first we are going to pattern match the turn to see what we are going to do first. So I'm going to do simply a match. So the return is, as mentioned, as I already said, it's not mandatory, but I added it in this case. So I would like to see the turn, and the turn can be a reset. I'm sorry, I'm a little bit maniac. Reset takes nothing, okay. And we have the play. We take a function, which is a function flip, okay. So in the case of the reset, what we would like to do is to return a new game, a brand new game with everything which is fresh, d'accord? Okay, so the heads, if we remember heads and nat, it should be a nat. So the heads should be 0 as nat, and the tails should be 0 as nat also. So that's why it's okay. One important remark here is you should put some parentheses, because here the compiler complained because you don't know if it's a record or if it's a block, okay? So since he's waiting for an expression, you have to mention this is an expression. I have to put some parentheses here just to prevent this is not the starting of block, but this is an expression. If it's this expression, it should be a record, okay? This is important. Then after, we can define a new block. So here I write a block, okay? And I say, okay, I would like to say my match. I want to play. And in order to know what to play, I have to apply my function flip with unit. So the way to do it is just to apply f to unit. And then after, I have different cases. Once I decide to flip my coin, I have a new head with no parameter, or I have the tails. Okay. We have two cases. In case of tails, I have to increase the number of the heads which has been returned. So once again, we're going to use the update procedure we already see before, with the heads which should be the previous heads. So I'm going to put in parentheses just to be sure, but I think we can remove it. I may remove it. So retrieve the previous heads, which came from the game G here, game which is here, G, and I add a new one. I increment with one natural, and so that's all. And since I'm going to do a copy paste, I know it's not a good one because I can do stupid things. Here I'm going to do the tails, and then tails +1. Finish. So here you can see we do a double match. The first one for the reset and the play, and the second one we use a parametric function which is flip, and flip, as you can see, is embedded in the constructor itself. Okay, play with a flip, and then after you have just to retrieve a brand new record, or just to alter this one, just adding the heads, incrementing the heads of the tails based on the result of the flip. So if I do the things correctly, it's okay for me. That's fine. Okay. So here in this example, we see function as a parameter, variant type, pattern matching, local function definition, update, access, transformation of an integer to a natural. Same here. I think we see all the topics in one thing, except the string concatenation in bytes. But in this small example, we see everything we learn during this day. So this, I think, this should be the last exercise, because we don't have enough time, and I don't know if I don't remember the name. Sorry, I'm so sorry. I retrieve it in Slack. I don't know if, whoops. Yeah, no, draft. No, I don't know if you have questions. You feel free to ask questions right now. I'm going to ask to unmute. Okay.
Hi, Didier.
Hi, we're finishing. It's finished.
Oh, awesome. Thank you so much. So I'm so sorry. I was on a different call. All right.
Yeah, no, I know, no problem, no problem. We still have 5 minutes for questions and so on, or more if you want.
Yes, absolutely. Okay. So first of all, thank you so much, Didier, for taking your time out and doing this. And also to everybody who's still on the call, thank you so much for staying back on the call and listening to everything. I hope you all learned a lot. Now, I would love for you guys to first ask questions about the workshop. Okay, Subhanshu asked, so the rest are exercise and we will cover them tomorrow. So we're going to have 3 more workshops tomorrow until Saturday. So different, They are all going to have different topics, but yes, all the doubts are going to be cleared out. So for now, can we have you, whoever is here, can we have you asking questions to Didier while he's here? If you have any questions, can you please ask them in the chat box?
So here we have the first one. Yeah, we have a first one, which is how the exercise will be covered tomorrow. No, the question is no, but the exercises are really simple. It's just the API usage and so on. So just to learn the API. So it's less important. It's not really how to say. One thing which would be important is the difference between map and big map. Because the capability to store a huge amount of data and how to retrieve it, consuming less gas. So I invite you to read documentation about big map and map, the difference between each structure. But then after we see how to do pattern matching. So option, you can do option easily. The list is the same. For the map, it's just an API. The set is just the same as list, but with a unicity of the value, of course. Exception is an important topic because this is the capability to abort the code as soon as possible. For example, once you retrieve information in your contract and you want to verify some, for example, functional constraint, and if these functional constraints are not, for example, verified, you should abort immediately. Why? Because, and this is really a pattern in a smart contract. Once something is going wrong, abort it immediately. Instead of doing something and so on, because otherwise you are going to consume gas for nothing. So exception is really important in order to prevent gas consumption in case of error. For example, once you have an error, drop an exception, and then after, poof, the contract is broken. It's not executed, and so you consume less gas. So exception is really important for this one. You have something about imperative style, so just the loop and so on. This is not too complicated at all. The recursive function could be complicated, but you have a different function. And the polymorphism, I think most of the code you are writing, you are not going to write polymorphic type and function. Mainly if you do some libraries, yes, but if you do contracts, I only see one contract with polymorphic data types, with what we call parametric types, which is a generic NFT. That's all. That's all. So no, it's quite easy, and you can follow. And once again, if you have question, do not hesitate. You can have question. You can ask question. If you have some issue, do not hesitate. Open an issue on the GitHub repository. Also, if you have some something to clarify or some, do not hesitate. Please help me to have a better material and so on. The feedback is really important for me. Okay, it's really, really important. Thank you so much.
All right, thank you, Didier. Yeah, I think there is a question. I have a general question. Tushar asks, related to Tezos ecosystem. I have some experience with Solana. How would you compare these two? Didier, are you comfortable answering this question?
Solana is written in which language is used by Solana? If we talk about the languages, it's Rust. Yeah, I remember Rust, because you have Solana in Rust and you have Cardano in Haskell. Primarily Rust. Frankly speaking, if we focus just on the languages, writing Rust is really difficult. It's really a difficult language, frankly speaking. Here, the experience we would like to offer to the end user to write contracts is to have a simple language with a simple construction, but expressive language. And I think that with LIGO, even with SmartPy and Archetype, we target this one, and we are able to do it. And then after, I never play with Solana. Of course, Tezos is better. No, it's a joke. You have the capability to use different languages. So for people coming from, for example, big data and so on, IA, prefer to use Python. People coming from the web prefer to use the JS something and so on. And the other ones you have to choose. So this is a kind of politics which has been chosen for Tezos. We should have different languages. And we are not trapped, for example, like Cardano with Haskell or Solana with Rust. And these languages are a really difficult one. So we would like to reduce the difficulty in order to increase the adoption and to let people use easily Tezos. So this is the only difference I see between Solana and Tezos. About the capabilities, I cannot argue about the capability and the facility you are in Tezos and Solana. I know there are capabilities. We have a protocol which is reviewed frequently with new features. You have the tickets which are coming. You have the roll-up. You have the chest. We are going to play with the chest and so on. And really is getting richer and richer. So I hope that Tezos is really a good platform to this. Yeah. And I play with Rust, and I know that Rust is really difficult. I do some presentation during conferences about Rust, and Rust is really a difficult language, a really difficult language.
Thank you so much, Didier. Anybody else has any questions? Please do drop it in the chat box so that you can ask Didier, and he will definitely help you out. All right, if you have no questions, could you just type in no so that we can have a unanimous thing so that we don't wait?
I have no question also.
All right, amazing. Okay, so I'll take it unanimously that you have no questions. And okay, there's one. How liquid POS is different from? I'm sorry, I don't know how I take this question. Could you answer this?
No. To be honest, no, I don't know.
Okay, all right.
I don't know. I'm brand new in the Tezos community. I'm brand new, so I'm starting, but I'm mainly focusing on the language right now, and I'm still learning the Tezos capabilities and so on. So I'm really sorry, I cannot answer. I prefer to say no instead of giving a stupid response.
Understood. Amazing. Anybody else? Yeah, I knew Sanket would actually answer this. That's great. Anybody else has any questions? All right, guys, then it's time. We've had an amazing session. I'd like to say thank you so much to Didier once again for joining and sharing whatever that he did. And also thanks to all of you who stayed until the end of the session. That means you are really, really excited to know more. And there are 3 more workshops that are going to happen tomorrow, day after, and tomorrow till Saturday, same time, 12:30. So do make sure you join in. And the Tezos India team will help you out with the links and everything as such. Make sure that you check your mail. All right. Thank you so much, Didier, once again. And thanks to all of you for joining in.
Yeah, same. Thank you for you. You have to join also, and to be patient during 3 hours. And do not hesitate. If you have questions, you have a Discord channel and